All right, new packet, and my phone has just, like, I've had lots of messages today. So Nisa is probably the last one. Amanda is going to be here, but late. And I've had 4 other, I'm not going to be here today. So one of those people requested that could they join via Google Meet or Zoom? And so I have Zoom open today. And so it means I still use the iPad, but I do it a little differently. And so hopefully I don't foul myself up a bit with that, but I think we'll be all right. Downside is new packet, and so anybody who does join online will not have that with them to have something to write with, but at least can kind of follow along. I did also post that on Google Classroom, the packet. And then I also printed out assignment summaries. So you guys could see like what your test grade was. And also if there were anything other papers that are missing or IXL assignments. If there's something that is missing, you are still welcome to do it. And so it's just more of a, hey, this was something I expected you to turn in. Like a reminder, you can think of it as a reminder at this point in the term. And then if you later want to see your test, to see what you actually, how you did or what you missed, then we can talk about that later. All right. So if you know how to graph, today's stuff is not going to be too bad because a lot of it just takes you back to graphing. And we have done inequalities before, but when we did inequalities before, we were just, oh boy, we were just on a number line. Okay, well, this is going to be interesting. All right, we were just on a number line, and now we will be on the coordinate plane, as you can see from the bottom of the page. So now we're going to be doing this in 2 variables. So we'll have X's and Y's. And we're going to be using, so inequality, as in we're using these symbols again. And I need to turn off my, who's annotating? Don't need to tell, it's only me. Hide the names of annotators. That's a little bit better. And so a solution to a linear inequality is going to be an ordered pair, because now that we have 2 variables. I should say ordered pair values, because there's not just one. There's a whole region of the graph that's going to satisfy it. So ordered pair values that make the inequality true. I'm having a hard time, can't blow up my screen, so I don't know that I can write small enough. It's going to be a shaded, so you can make yourself add a little bit more in here. It's a shaded portion. So we're going to shade a portion of the graph, and that shaded portion are all the places where there are points that would make the inequality true. So in this example, if we were asking which of these ordered pairs would be solutions, we can plug them in like we have numerous other times. We can plug them in and then check to see if they make it true. All right, I remember now. So go out and back in. So I can do 2 times 2 minus 3 times 5. And then C, is that less than 15? Well, 4 subtract 15, that's negative 11. Negative 11 is less than 15. That is a true statement. So then, yes, this one, or which one is, this one is a solution. So if I try that same thing for the second one, we're going to be multiplying 2 times -1. So that's -2. -3 times -7, +21. And then even before I finish the math, I can kind of see pretty quickly that that's going to be not true because it's going to give me a bigger number than 15. So this is not true. So it's not a solution, or I would say no, not a solution. Stay. So 2 times 3, 6. -3 times -4, 12. Is 6 plus 12 going to be less than 15?
No.
No. Also not a solution. How about 0 and 0? Well, 0 minus 0 is 0, right? Because 2 times 0, 0, 3 times 0, 0. 0 is less than 15. So yes, this is a solution. So those are not the only 2 points, but those 2 points are solutions. They would be in the portion of the graph that would be shaded if we were to graph this, because just like the number line, how it wasn't just one number, it was a whole range of numbers. This is a whole like section of the graph that could make this true. So we're going to look at how can we graph this and then show the whole solution set on the graph. And that's what our next notes are about. So first we're going to put the inequality in slope intercept form. And let's see, I have to remember how to do this. Clear, not the slope intercept form part, the clearing my screen on Zoom. All right, so turn that back off. Turn this off. Get rid of him. All right. Try to blow this baby up. Okay. So put the inequality in slope intercept form. Even if you could graph the line without it being in slope intercept form, having it in slope intercept form is going to make it easier for us to know if we need to shade above or below the line to know which direction. So when we are moving it around, if we have to divide or multiply, it's typically divide. If we divide by a negative number, that inequality sign in the symbol in the middle has to flip. It's going to change. And we'll have that first example is like that. When we graph the line, we will use a solid line if it is one of the ones with the equal line. So my greater than or equal or my less than or equal gets a solid line, like the solid filled in circle. And we will use a dotted or dashed. I usually call it a dotted line, but how I make it usually looks more like dashes. But basically the deal is that there are openings in the line because the boundary line is not included as solutions. So places that would make it exactly equal would not be actual solutions because it doesn't say or equal. And then after we've graphed the line, then we're going to shade, and we will shade above the line, like higher, if it is greater or greater equal to, greater than or equal to. That is supposed to be above. There we go. And we will shade below the line if it is less than or less than equal to. Now let's think about why the above and below because we're going to have the y by itself. So we're saying that the y is greater. And where are the y's greater? Higher on the graph. Undo that. Turn that on. So for this first example, first we put it in, we're going to follow through the steps that we just said, step 1, step 2, step 3. First, sloped intercept form. So we're going to move the 2x over to the other side. We know when it moves over, it becomes negative 2x. Because to move it, remember, you'd have to subtract it. So to get rid of it on the left, we'd have to subtract it. So when it gets to the right, it's negative 2x. Divide everything by that coefficient of y, which in this case is negative 3. So every part is going to get divided by negative 3. And we did divide by a negative. So this symbol changes direction. It does not grow an equal line, but less than becomes greater than. And then 2 negatives in the same fraction means the slope is now positive. And 1 negative here gives me negative 5 for our y-intercept. So that was all step 1, putting it slope intercept form. Step 2, we're going to graph the line. So I'm going to start at negative 5, which in this case is all the way at the bottom of the graph. And then from here, I'm going to go up 2 and over 3. And this is not supposed to be solid. It should be a dotted line because the boundary line is not actually places that make it true. So dotted, dashed, whatever you would like to call that. And then we're going to shade above the line. Now, in this case, it might be obvious to you which way is above the line. When it's steep, sometimes that looks more like left and right. But if you think about the y-intercept, this y-intercept is negative 5. Where on the y is it greater than negative 5? Would be all of these places. So it's everything on this side of the line. So even all of that to the left, because this line would be extending this way, dotted, but extending this way. So all of this is shaded. So if you were kind of lazy before about not extending your line, be sure that you extend your line. Because if you don't extend it, then like where does the shading stop? So for instance, if I did not extend my line over here and I just stopped right here, well, then when I'm doing my shading, like where do I go? So be sure to extend your line throughout your graph. All right, so turn the page and we're going to try a few more of these. Sometimes you're going to get kind of off a little easier in that it may already be in slope intercept form. So for instance, number 1 and 2 here are already in slope intercept form. Sorry. Here. I have to make sure I turn my pencil off before I try to pinch in or out. That's why I'm getting those random marks. I have to like remind myself. So we're going to start at negative 5. And then up 1 and over 3. So the y was already by itself. We didn't have to worry about doing more. I'm going to go ahead and go up 1 over 3 again and again. Now, if you accidentally make a solid line, you could just go back and like erase pieces of the line. And then will I be shading above or below this line? Above. Okay. So now I'm going to shade above. Now, after you have your things done, you could confirm that your shading is correct. It doesn't really confirm that your line is correct, but you can confirm your shading is correct by choosing a point in the shaded area, and it should be true. As long as if 0, 0 is not on your line, it's a great place to check because it's an easy place to check. So if I choose 0, 0 to check, I in this problem would want it to be true. 0 is greater than, and this whole thing would be 0. So 0 is greater than -5. That's true. That helps me confirm that my shading is in the right place. So I can use 0, 0, even if it's not in my shading. If it's not in my shading, I would want it to be false. And that confirms that I need to shade on the other side. So you can kind of check things, at least the shading portion, by plugging in, and it doesn't have to be 0, 0. It just so happens that that's an easy place. So this next one, start at -1. Turn my pencil back on. And then down 2 over 1. And you could just keep following that pattern, or you could grab a ruler to make sure you get a fairly straight line. And then we're going to connect and extend. This time it is a solid line. And I know mine is probably, whoa, hello, not way off, way off there. Okay. Pretend with me. And then this time it is less than. Well, my line's getting a little more straight up, so it may again help to think about on the y-axis, less than -1 would be down here. So since these things need to be shaded, it's everything on this part of the graph. It has to be on that side of the line. And then of course, if it is not in slope-intercept form, we need to put it in slope-intercept form. And if the y starts out negative, you will at some point be dividing by a negative. And so your symbol is going to change direction, which means then your shading is going to be on the opposite side of where it would have been. So for 3, I'm going to move my x over and divide by -2. So I end up with y is less than 5 over 2x minus 6. And that's after I've moved it over and divided everything by -2. And then this is back to graphing from slope-intercept. So we're starting on the y-axis, 2, 4, 6. There we go, where you at, 6? 2, 4, 6. And then up 5 and over 2. And I could go up 5 and over 2 again. Kind of hit and miss here, but dotted line. And my shading should be below the line. So -6 Below that on the y-axis would be this part down here. So if that's on this side of the line, so this side of the line is the stuff that would be shaded. So if there is a y and we get it by itself, then the shading, we think above and below. But if you look at number 7 and number 8 on this page, on 7 and 8, there is only a y and only an x. So we need to remember about our horizontal and vertical lines. So if there is only a y, is that going to be a horizontal line or a vertical line? Horizontal. Right. So we're going to go to -4. 1, 2, 3, 4 on the y. And we would go straight across 1, 2, 3, 4. And then we can still think of above and below. Where are the y's less than -4? Down here, below this. When it is only x and it is a vertical line, then it's not y that's greater or less. It says x. So x's are greater to the right because that's where the x's get bigger. So we would go to 7, see 10, 9, 8, 7, vertical line, dot it. And then where the x is greater than 7, to the right of that. So it would be this side. So that's the one time that I can't think above and below. If it's a vertical line, then to the right is greater, where the x is 8, 9, 10, and so on. Or to the left is where the x would be less. Okay, so you have 12 problems on pages 3. Okay, I guess that's supposed to say 2, but the bottom of it got knocked off. On pages 3 and 4, which is the next 2 pages. And then I'll give you guys some time to work on that. And then we're going to look at systems of equations, starting on page 5. There are 3 basic things that can happen. The 2 lines cross, and where they cross is the solution, and you write it as an ordered pair. The 2 lines never cross because they're parallel. And then there's no solution because there's no place that can make both of them true. Or the 2 lines actually could be the same line. The 2 equations could be the same line. And then there would be infinite solutions. So if there's only one solution, that's just the point they cross. So if there is an intersection point, then we can check it by plugging it into both equations. So if I graph both lines, so graph the first line, graph the second line, there's not shading on these. Okay, graph the first line, graph the second one, tell me where they cross. If you want to know for sure that where they cross is true, then you plug the x and the y in to both equations to make sure that it's true. So if I am going to graph this, I start at -8 and I'm going up 1/1. And I need to be sure that I'm careful. So I usually use it several times because if I'm not careful, then my line drifts and then it's hard to know where it crosses. The other one starts at 1 and goes down 2 and over 1, down 2 and over 1, down 2 and over 1, which I believe is there, which would be 3,